lesson, I'm going to go over how we're going to use all of these trig identities to help us prove some of these trig equations. So essentially, the way I kind of treat these is first I need to have my identities memorized. So you've got the three Pythagorean identities up at the top. We've got our quotient identities, which we've already kind of talked about, tangent, but there's cotangent. You can see it's the reciprocal. And then we have already talked about the reciprocal identities. So we're going to use all that information to help us make one of the sides of the equation look like the other. Okay, so we will have a quiz over these identities before we take a test on this unit. So it'll be something that you will have to have these memorized before we actually sit down and take the big summative test. Now, this is kind of the process that I'm going to go through. I'm going to pick one side. Usually, it's easier to start with the more complex side, and then use my understanding of the identities of algebra to help me try to make it look like the other side of the equation. All right. What I do is kind of a last resort. If I get stuck, right, you're going to find out when you try these on your own. There can be some that are going to require some serious persistence. Like you're going to be like, man, this is super frustrating. I don't know what to do. But at the end of the day, if I get stuck, I try to convert everything to sine and cosine and go from there. All right. So again, just like most things that you're going to do, not just in this class, but in life, the more you try on your own, the more you work through the frustration and not understanding, the easier it will become. So we'll be doing some delta math questions together. But again, it's going to come down to, are you going to put in the time to do those questions? All right, so let's go over a few together. All right, so the first one says to verify that the tangent of theta times the cosine of theta is equal to sine of theta. All right, so what I do is I pick a side. The left side has tangent and cosine multiplied together. So I'm going to choose those trig functions to try to manipulate them, rewrite them using my identities to make them look like just sine theta. All right. So I'll do my best here. It's not going to be perfect. Try to show kind of everything my brain is thinking. But 9 times out of 10, when I see tangent of theta, I'll be using the understanding that tangent is the same as sine over cosine. So I'll write sine of theta over cosine of theta times cosine of theta. And one thing I'm going to try this year that I haven't really done in the past is to the side in a different color, I'm going to put the identity that I used. So tangent of theta equals sine of theta over cosine of theta. Okay? So that can hopefully, when you check your work, you can see like why, where did I get that? It didn't just pop magically into my head, right? I know this identity. Okay? Remember, ultimately, at the end of the day, I'm trying to get this. So I'm still not there yet. So I'm going to rewrite it, and I'm going to put a 1 underneath cosine theta. And maybe you'll see that when we multiply, we actually can cross out diagonally. And when we cross out diagonally, the cosine thetas will cross out and make 1. So now I have sine of theta over 1, which is just the sine of theta. Remember, I wanted it to be equal to sine of theta. So really this question came down to understanding this one identity, right, which is the tangent of theta equals the sine of theta, one of our quotient identities. Let's try another one. It says verify the identity cosecant of theta, cosine of theta, tangent of theta is the same as 1. I think this one is pretty simple to decide which side you're going to use to manipulate. You're not going to use 1. All right, you're going to use the one that has 3 different trig functions. So I'm going to first change cosecant to be the reciprocal of that, which is 1 over sine. So I'm going to write 1 over sine of theta. And I'm going to go ahead and just put these as their own fractions. All right, and again, I'm going to show a different color. So what I used was cosecant theta is the same as 1 over sine of theta, one of our reciprocal identities, right? We've been working with reciprocals for a while now. All right, I'm going to put the cosine and sine together, right? Cosine theta times 1 is cosine theta. sine of theta times 1 is sine of theta. All right, and then I'm going to rewrite tangent of theta as sine of theta over cosine of theta, which is actually the same quotient identity that I used on the previous one. So tangent of theta equals sine of theta over cosine of theta. Okay, now at this point, you should notice that if I just look diagonally, I'm actually able to cross out everything, right? Cosine divided by cosine is 1. Sine divided by sine theta is 1. So that's why this is just 1 equals 1. So we were able to get 1 in the end. Okay, let's do the same thing here, all right? Now, this is going to be a little trickier, all right? But when I look at this one, I look in the numerator and I see secant squared theta and the number -1. All right, so one of my identities, right, from the first page is a Pythagorean identity right here that says 1 plus tangent squared theta equals secant squared theta. So let me do a little work to the side. I'll use my different color to show you what I'm doing here. So 1 plus tangent squared theta equals secant squared theta. All right, now that I don't have that, but if you look in the numerator, you can see that I'm one algebraic move away from actually having that. So if I subtract 1 from both sides, then I have tangent squared theta equals secant squared theta minus 1, which is what I have in my numerator. So I am going to replace, right, I'll highlight here, I'm going to replace secant squared theta with tangent squared theta. So I'm going to write down tangent squared theta over secant squared theta. All right, so this was the work that I used for that numerator, changing it to tangent squared. All right, let's go and split that up. Tangent squared theta over 1 divided by secant squared theta over 1. I think we're okay with that. Then I'm going to think back to middle school, and when I divide a fraction, I actually multiply by the reciprocal. All right. Now, I know it says squared, but one of the nice things about these quotient identities, and even the reciprocal identities, is that if this just says squared, then you just have to change the sine to be squared and the cosine to be squared. So as long as you throw the squares on all of the trig functions, then it's okay. Like, for example, sine squared theta is 1 over cosecant squared theta. So that's what I'll be using to rewrite this first one. So tangent squared theta, I'm going to rewrite as, sine squared theta over cosine squared theta. So let's put that here. And then I'll use my different color to show you what I just did. So I just did tangent squared theta equals sine squared theta over cosine squared theta. And then if I want to rewrite 1 over secant, right, I know the reciprocal of secant is cosine, and 1 over secant is actually cosine. So it's actually cosine squared theta on top. So it's up to you on how you write this. You could write 1 over secant squared theta equals cosine squared theta, or you could write cosine squared theta equals 1 over secant squared theta. I don't care the order as long as you know that they are reciprocals. And then at this point, you should see that we're now able to cross out, right? Look diagonally. Cosine squared theta will make 1. So my answer is just sine squared theta. I know it's a long problem, but if you look, that is what I wanted in the end. I wanted sine squared theta. Okay, I'm hoping that after this one, first off, thanks for watching the video. But if you made it this far and you watched me do that one, your first thought is probably like, whoa, that's a lot. And guys, it is, right? I'm not going to lie to you and say this is simple stuff. This is challenging stuff. It's almost like I don't really play chess because when I was a kid, it was very challenging and my dad would just crush me. And I was like, yeah, this isn't really for me. But when I do these, I kind of think of it as like chess. Like I'm about to make a move, but I do my best to be like, okay, after I make this move, what's coming next? am I able to kind of see a couple moves ahead? And when you start, there's no way you'll be able to see. So really, this is just going to be give it your best shot. And if you get stuck, erase and start over or go back to where you feel confident. You just got to try. There's no substitute for you just trying to do these on your own. Okay? All right, let's try this next one here. It says show that cotangent of theta divided by cosecant theta is equal to cosine theta. Lots of C's here. All right. I'm going to choose the left side to manipulate to look like the right because it's got two trig functions being divided. And I'm going to split those up. So cotangent of theta over 1 divided by cosecant of theta over 1. All right. Remember, go back to middle school, multiply by the reciprocal. All right. When in doubt, if you're like, I don't know what to do, nothing crosses out, always convert things to be in sine and cosine. So we've used twice now, maybe even 3 times. We've used the quotient identity tangent of theta equals sine over cosine. But the other quotient identity up here is the cotangent of theta equals cosine of theta over sine of theta. So that's what I'm going to use to rewrite cotangent. I'm going to write this as cosine theta over sine of theta. And I'm going to put my work here. Actually, let me first copy this down. All right, choose a different color to show you what I did. So I use cotangent of theta equals cosine theta over sine of theta. Okay, still unable to cross out, but I notice I see cosecant, which is a reciprocal of sine. So copy down cosine of theta over sine of theta, and times 1 over cosecant of theta is actually sine theta. All right, so that one I used. Again, kind of like the last one, I don't care the order that you write it. So I'll change the order this time to see if we're okay with it. So sine of theta equals 1 over cosecant of theta. Okay. Now, if I look to my diagonals here as I multiply, I can cross out sine of theta over sine of theta and just end up with cosine of theta, which is the right-hand side. That's what I wanted. Now, I will say, as you start to do these, and especially when they're really tough and there's a lot of work involved, the joy that I feel when I get one of these right is amazing. I really enjoy it. So hopefully that's you. If not, do your best. Okay, let's try this one. All right, got a lot of room here. So it says verify the sine squared theta minus 1 over tangent of theta times sine of theta minus tangent of theta equals sine of theta plus 1 over tangent of theta. Now, you can make an argument for either side, right? Both look pretty confusing, but I would argue that the left side looks a little bit more complicated. You've got a sine squared on top, and you've got not just tangent of theta in the bottom, you've got tangent of theta times sine of theta minus tangent of theta. So I actually am going to choose the left side to look like the right side. Now, the first thing I notice in the top, right, is that this is the difference of two squares, right? The sine squared theta, I know it's kind of weird to say it, right? You can think of it as like x squared minus 1. And you guys hopefully know how to factor that from last semester or even algebra 2, right? So that's how that factors. But obviously it's not x squared minus 1. It's sine squared theta minus 1. So I'm going to factor out this to be the difference of two squares. So sine of theta minus 1 times sine theta plus 1. All right, and so I'm going to write down, let me copy down the denominator first. So tangent of theta times the sine of theta minus tangent of theta. So in my, my algebra work that I did here was I did dots. All right, which is exciting. Now, the numerator is going to stay how it is, but I'm going to factor out something in common in the denominator. And if you look in the denominator, you should notice that we have tangent in both terms. So I'm going to factor out tangent of theta, right? And then when I divide tangent of theta from both those terms, I'm left with sine of theta, and then minus tangent of theta divided by tangent of theta is actually minus 1. All right, so I'll put my work here is factor out tangent of theta. Okay?
So now at this point, I'll notice that I can cross out something, right? I can cross out sine of theta minus 1 and sine of theta minus 1 at the top and the bottom. And I'm left with just sine of theta plus 1 over the tangent of theta, which, if you notice, that is what I want. I want sine of theta plus 1 over the tangent of theta. So we were actually able to get there without actually having to use any trig identities, right? We didn't have to use any Pythagorean identities. We didn't use any reciprocal or quotient identities. We just used algebra, right? Which I know seems kind of unfair to all of a sudden just throw this algebra back at you, but that's the deal. You got to be solid with your algebra, even as we're making our way through the world of trig. Okay, let's try another one. Okay, so this one is saying to verify that 1 minus cosine squared x times 1 plus cotangent squared x equals 1. Now, if you wanted to, you could distribute these, but the moment I see the number 1 with a trig function squared, I'm hoping, right, fingers crossed, I can use a Pythagorean identity, right? And that's one of the reasons that we have to have them memorized, is because at this point, if you don't have them memorized, you're like, I don't know what to do. All right, so let me check to see. I'll do the cosine squared one first. So let's change colors to show you the work I'm going to do. One of the Pythagorean identities is sine squared x plus cosine squared x equals 1. Okay, so I want to get the cosine squared x to be on the same side as 1 with some algebra. So I'm going to subtract cosine squared x from both sides. And when I do, I'm left with sine squared x equals 1 minus cosine squared x, which if you look, right, that is what I have. So I'm going to go ahead and do a little work here, right? 1 minus cosine squared x is the same as sine squared of x. So let's go ahead and replace 1 minus cosine squared x with sine squared of x. Now I'm going to go ahead and keep the 1 plus cotangent squared x for now, right? But all of this work that I did was to replace that first term. All right, so now let's do the same thing for 1 plus cotangent squared x. So one of the other Pythagorean identities is 1 plus cotangent squared x equals cosecant squared x. Now this one requires no manipulation. You'll notice in the parentheses, I'll use a different one, where these parentheses, that's already there, right? 1 plus cotangent squared x is already there. So I'm just going to replace it with cosecant squared x. So copy down the sine squared. And this is going to become cosecant squared x, right? Now, again, I want this to be 1. So I'm not there yet. So that was my second step. But I notice I have cosecant. Yeah, I know it says cosecant squared. But cosecant is the reciprocal of sine. So I'm going to copy down sine squared. But I'm going to rewrite cosecant squared as 1 over sine squared x. And similar to what I said on an earlier problem, that if you use one of the identities, like the reciprocal identity or a quotient identity, if it has squared, as long as you make what you convert it to a square, it's fine. So what I'm trying to say is cosecant squared x is the same as 1 over sine squared x. So that's a reciprocal identity. Okay, and now you should see that as we look diagonally, we're going to be able to cross out. And so it's 1 times 1 over 1 times 1, which is just 1, which is what I wanted. I wanted 1. All right, so again, I cannot stress this enough, right? As you're trying to do these, just be patient, try your best. If it's not going well, start over and use a different strategy. The payoff when you persist through this is going to help so much as you go through and try to do these. I will say in teaching trigonometry, this is where students start to really, 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 really struggle. And, the persistence is a key issue there. So try to push through. You got to practice. And I'll do my best to support you in that practice. All right, last page. All right, now just a little bit different. All right, it's going to feel very similar for some of these. But these first two here, I wanted to just take a moment and kind of remind you that just because we've moved into trig doesn't mean we've lost our algebra skills. So these first two are asking us to take these trig expressions and rewrite them as algebraic expressions. All right, so I'm going to actually end up going back to the trig on both of these, but I will show you the algebra that we'll do in the work. So let's try the first one. The first thing I want to do is actually just have you substitute x for cosine of theta. Because if I do that and make this 2x squared plus x minus 1, I think you'll think, oh, okay, I've factored stuff like this for years in my algebra classes. All right, so what I'm trying to teach you guys and teach our classes with the underclassmen moving up to the upperclassmen is to use the slide, divide, bottoms up method when I see this 2 in front. So I'm going to slide it to the back and get x squared plus x minus 2. Go ahead and factor this how you normally would. What are factors of negative 2 that add to 1? And that's going to be positive 2 and minus 1. But again, that's not what it is, right? I manipulated the problem to become that. So you've got to put these two numbers that I chose over that number that I slid, which was that 2 in front. The first one is going to simplify nicely. 2 divided by 2 is 1. But because 1/2 doesn't simplify anymore, you actually slide this 2 up to the front. So you get 2x minus 1. All right, so this is what, hopefully, in terms of your algebra skills, you can factor that quadratic trinomial into those two binomials. And so all we would do then is just replace where it says x, we would go back to our cosine of theta. So I'm going to write cosine of theta plus 1 times 2 times the cosine of theta minus 1. Right? And technically, it didn't make me do that because it just wants me to write it as an algebraic expression. But I want you guys to get practice of going back to that, just because when we set this equal to something, you're going to have to keep going. All right? So that's that one. Let's try this one. It's telling us to use the difference of two squares, right? So this is just shouting. As you guys know, I love to shout dots, right? The difference of two squares. So again, if I change the x to be cosine theta, I have 4x squared minus 1. So if you remember how to factor this, you take the square root of both. The square root of 4 is 2. The square root of x squared is x. And the square root of 1 is just 1. Make one subtraction, make one addition, and you're done. Right? But as I want you to practice is to put the trig back in. So 2 cosine of theta minus 1 times 2 cosine of theta plus 1. All right, and again, you'll see in a later lesson in this unit, we're going to have to solve this equal to some value, and that will require you to have that basic understanding from the first unit as well, the trig basics. So all the stuff we've been doing is building on each other. You can't just forget it now that we've moved to a new unit. All right, let's do 2 more. Simplify this expression by rewriting and using identities. So for this one, the way I'm thinking is I see cosecant is squared, I see cotangent is squared. So my thought is maybe it's going to be one of our Pythagorean identities. So I'll do that work to the side here to see if I can manipulate. And sometimes, guys, I'll be honest, I think it is Pythagorean identity, and then I go to manipulate it, and it just doesn't work. So like you got to get creative. If it doesn't work, maybe try something else. So the one I'm thinking of is 1 plus cotangent squared theta equals cosecant squared theta. So is there a way algebraically I can manipulate this to make it look like what I'm given? And if I subtract cotangent squared theta from both sides, I think I can. So this is going to be 1 equals cosecant squared theta minus cotangent squared theta. And then what do you know in my problem? Right? Cosecant squared theta minus cotangent squared theta. I just manipulated. That is the same as the number 1. So this whole thing just becomes 1 because of all of that work. Okay. Let's go ahead and try this last one. All right. So it says, use algebraic techniques to verify the identity. Cosine of theta over 1 plus sine of theta equals 1 minus sine of theta over cosine of theta. So actually, they look pretty much the same in terms of complexity. And there's a couple of ways you could do this. I'll do the way that my brain first went to, which is using my understanding of something that I did in algebra called rationalizing the denominator. Or if you want to think of the way we did this with imaginary numbers, it was multiplying by the conjugate. Now, you may not remember any of this, but it is definitely a trick, a technique that you will need to know and need to practice in order to be successful on doing these. So I'm going to choose the left side. All right, and what I'm going to do is I'm going to multiply the left side times 1 minus sine of theta over 1 minus sine of theta. So this is, I'll write it to the side here. My brain is thinking multiply by the conjugate. So you'll notice I just copied it down, but I made the sign in the middle the opposite. So by doing that, what that does is the numerator is just going to be those two things multiplied together. But you'll notice I'm not actually distributing them. But when you distribute the denominator, I don't know if you guys remember this, when you multiply these conjugates from your days in imaginary numbers, is actually the middle term will make 0, right? So when I get to 1 times negative sine theta plus sine theta times 1, those are opposites, and they make 0. So really, this is just 1 minus sine squared theta. All right? And again, as I mentioned, when I see the number 1 and when I see one of our trig functions squared, I'm thinking, maybe this is a Pythagorean identity that I can manipulate. So I'm going to do sine squared theta plus cosine squared theta equals 1. All right, let's manipulate this by subtracting the sine squared theta to the other side. And that leaves me with cosine squared theta equals 1 minus sine squared theta. So when I look here, right, again, do my highlighting, I've got 1 minus sine squared theta in the denominator, which is the same as, after I manipulated it, cosine squared theta. So let's go and replace that, which will be cosine of theta, don't touch the numerator yet, over cosine squared theta. Okay, so that's all that work I did there to replace the denominator. And then the last thing is, oh man, battery's about to die. Gosh, I need to get a new surface. My last thing is, did it die on me? No, okay. Whew. Don't die. Please don't die. My last thing is, I notice I have a cosine of theta at the top, cosine squared theta at the bottom, and so I can actually, I guess I'll show my work here, right? Cosine of theta over cosine of squared theta equals 1 over cosine theta, right? When you cross out, kind of like your days in algebra or even pre-algebra when you had x over x squared, it's just an x in the bottom. So that means I'm going to have 1 minus sine theta in the top, and in the bottom I'll have 1 cosine theta, which I know it's hard to believe, but that is actually what I wanted in the beginning. I wanted 1 minus sine theta over cosine theta. So we were able to prove this identity. Okay, so as I mentioned on all of these, I'm finished now. They are not simple, guys. This is not simple, and I apologize. This is the first lesson in this new unit, but I just need you to know up front, right, to kind of be ready for how difficult this can be. And we'll be doing practice problems in class. We're going to work hard on the Delta Math links to practice and make sure we're experiencing this frustration and trying to work through it, because that's the only way to get better at this. All right, so good luck.